First way to express our answers in simplest radical form. So we are looking for the perfect square that divides in 125, and it is 25. And it goes in 5 times. We take the square root of 25, which is 5, so we have 5 roots of 5 is equal to c. The other way to express your answer is to write it as a decimal. And generally we write it to the nearest 100. So if I take the square root of 125, I get 11.18, or approximately 11.2. Okay. This should be longer than the two other sides because it's the longest side of the triangle. What's different about the second problem? We're given the hypotenuse, we're missing a side. It doesn't matter whether you call this A or this A, just make sure that those sides of the right angle are A and B. The hypotenuse is letter C. And so we set up A squared, or 6 squared, plus B squared is equal to 13 squared. 6 squared is 36, and 13 squared is 169. B squared is, we take 169, we subtract 36. And I get 133. There is no number that divides evenly into 133. That's a perfect square. If we take the square root of it, we get 11.5 approximately. Please try number 3 on your own. Try number 3 on your own. Yes. Okay, I should see A squared is equal to 13, I'm sorry. I should see A squared plus 169 is equal to 225. So A squared is equal to, what did you come up with 225 minus 169? 56. Take the square root of both sides, we get A is equal to the square root of 56. Which has a perfect square that divides evenly. The perfect square goes in is 4. 4 divides in 19 times. So the simplest radical form is 2 roots of 19. 2 roots of 19. If you're to find that exact value of that square root, we would do the second square root of 56. We'll get 7.5 approximately. Yes. You should be prepared to show both of them. Okay. All right, let's try a classic word problem. An 18-foot ladder is leaning against a building. The building, we've got a door down here. Got some windows up here. And I'm going to lean this ladder against the wall. So it says the ladder is 18 feet tall. The bottom ladder is 6 feet away from the base of the wall. How far up the ladder does, or how far up the wall does the ladder reach? Where do I put my 18 and my 6? The 18 goes on the ladder because it says the ladder is 18 feet tall, and then this bottom part here is 6. The question is, how far up the wall does it reach? I'll call that B. And so we have 6 squared plus B squared is equal to 18 squared. 6 squared is 36. 18 squared is 324. I subtract 36 and I get 288. And most commonly in these situations, when you're asked to find a distance that's used in real life, especially like height up the wall, they'll simply ask you to write the answer, say, to the nearest 10th. So let's take the square root of 288. Second square root, 288. You can see that you get 16.97. Or about 17 feet. I got to use that this year. One's option. All right, we flip it over. So from the Pythagorean theorem comes something called the distance formula. Okay? If I have 2 points and I want to find the distance between them, I use the Pythagorean theorem. We'll show you how it works. We're going to call this point x1 and y1. We're going to call this point x sub 2 and y sub 2. Now, if you look at this coordinate, it has an actual location. It's back 2 and down 3, so I'm going to write -2, -3. And then this has a coordinate value, +2, +2. So if we are going to use the Pythagorean theorem, notice that we can find this distance right here. What's the distance of this leg right here? What's this leg's length? We just have 4 units. Or in other words, that's just subtracting the x values. 2 minus -2. So x sub 2 minus x sub 1. That's my a squared. Plus, let's find this distance right here. What's the distance of this leg? We went from -3 up to 2. That's a length of 5. Or in other words, your y sub 2 value minus your y sub 1 value. 2 minus -3 is 5. So y sub 2 minus y sub 1. And that's equal to your distance squared. Notice it's a squared plus b squared is equal to c squared. We just have different things in those positions. And then if you want to solve for d, you just take the square root of both sides. And you come up with this formula. Distance is equal to the square root of, and it's x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared. And that's our distance formula. I'm going to show you two ways to find the distance. And then we're also going to find the midpoint. We will do the distance first. Yep. I think the easiest way to determine the distance is simply to just use the Pythagorean theorem. I make a triangle. What's one leg? This leg has a measure of 4. The other leg has a measure of 6. So if you want to find the distance, we have 4 squared plus 6 squared is equal to d squared. Or 24 plus 36 is 24. Sorry about that. 16 plus 36 is equal to d squared. 16 and 36 make 52. And I square root both sides. The perfect square that divides evenly at 52 is 4. So I have the root of 4 times the root of 13, which is 2 roots of 13. Try to find a distance for the next one on your own. Go. Excuse me. Where we come up with that? Square root of 73. Good. So if you're given a graphical representation, just go ahead and use the Pythagorean theorem. If you're not given a graphical representation, use the formula. I'll write down the formula for you. Distance is equal to the square root of, and it's x sub 2 minus x sub 1 quantity squared, y sub 2 minus y sub 1 quantity squared. Like that. What's x sub 2? Which one? 3, negative 2, negative 1, or negative 3? Yeah, it's negative 1. Minus the first one, which is 3. I'm going to square those. Plus my y sub 2 is negative 3 minus negative 2. Now, please be careful because people mess up their negatives. No reason for us to make that mistake here, okay? Negative 1 minus 3 is negative 4. And when you square a negative, it becomes positive. So make sure all these numbers underneath here are positive. So 4 squared is 16. The negative 3 minus the negative 2, remember you add the opposite. And so you get a negative 1. Squared is 1. So we get square root of 17. Try the next one on your own. X of 2 minus x of 1 quantity squared, y of 2 minus y of 1 quantity squared. Square root it all. See what you get. Get square root of 125. And we already reduced that to 5 roots of 5, right? Okay. All right, last piece we need to do is just also determine the midpoint. This is the formula for distance. We have one more formula for midpoint. And the midpoint is simply the average of the x values and average of the y values. So it's a coordinate. How do we find average? You add up everything and divide by the number, right? So we're going to add up the x values. x1 plus x2, and we divide it by 2. And then to find the average of the y values, we do y1 plus y2, and we divide that by 2. I'll give you these formulas on the test. You got to know midpoint, got to know distance. And I think it's easy to remember because, again, the distance formula is just like Pythagorean theorem. The midpoint formula is just all about averages. So we're just going to do these bottom two. I'll show you how simple it can be, okay? Midpoint. We're going to add our x values. What do you get when you add your x values? 2. Divide that by 2 and you get 1. Go to our y values. Negative 2 plus negative 3 is negative 5. So you get negative 5 over 2. That's your midpoint. That's it. Midpoint here. Add the x values, you get 6. Divided by 2, you get 3. Your y values, negative 7 plus 4 is a negative 3. Divided by 2, got that negative 3 halves. That's it. Your assignment is very, very short. It's just the front page. That's all you're being asked to do. Okay. Should have some time to work here. I'll hand out your tests in just a second.